Hey, welcome. This course is all about functions in Python. And honestly, if there's one thing that'll level up your code the most, it's this. Doesn't matter if you've been writing Python for a week or a year. Functions are the thing that separates messy spaghetti scripts from clean, professional code. By the end of this, you won't just know the syntax. You'll actually get why functions are designed the way they are, and you'll have the instincts to use them well in real projects. Let's get into it. So why do functions matter? Think of it this way. Imagine a chef who has to reinvent a recipe from scratch every single time they cook. That'd be insane, right? Functions are your recipes. You write the logic once, give it a name, and call it whenever you need it. No copy-pasting, no duplication. In this course, we're going to cover everything from the basics, what a function actually is, all the way up to decorators, recursion, and lambdas. And we'll tie it all together with real-world Python projects. The goal isn't just to write functions that work, it's to write functions that your teammates and future you will actually thank you for. Alright, let's nail down the fundamentals. A function is basically a named, self-contained block of code that does one specific thing. You define it once, and you can call it as many times as you want, from anywhere in your program. Every function has four key parts. First, the name. That's the identifier you use to call it, so make it descriptive. Then parameters. Those are the optional inputs you pass in. Then the body. That's the indented block of code that actually runs. And finally, the return value, the optional output the function hands back to whoever called it. Get comfortable with these four pieces, because everything else we cover builds on top of them. Okay, let's write some actual code. To define a function in Python, you use the def keyword, short for define, followed by the function name, a pair of parentheses, and a colon. Then everything indented underneath is the function body, so def greet. With a print inside, that's your first function. You call it by just writing greet open parenthesis, close parenthesis. Now if you want to pass data in, you add a parameter inside the parentheses, like greet underscore user open parenthesis, name close parenthesis. And then you can use that name variable inside the body. One thing to watch out for. Python uses indentation to define the function body. 4 spaces is the standard. If your indentation is off, Python will throw a fit. It's one of the most common beginner mistakes, so just keep an eye on it. So once you've defined a function, calling it is dead simple. Just write the name with parentheses. And here's where the real power kicks in. You can call that function 10, 100, 1,000 times, and the logic only lives in one place. So if you need to change the behavior, you change it once, and it updates everywhere. Under the hood, here's what's happening. Python's running your script top to bottom, it hits a function call, it pauses the main flow, jumps into the function body, runs all those indented lines, and then returns control right back to where it left off. That's the call stack in a nutshell. It's a simple concept, but understanding it will save you a lot of confusion when you start debugging. Functions get really useful when you can pass data into them. That's what arguments, or parameters, are for. With positional arguments, the values you pass in get matched to parameters in order. So if you call add open parenthesis 3, 5 close parenthesis, then inside the function A is 3 and B is 5. Simple. And Python's duck typing means this works with any compatible types. You can pass in integers, floats, even strings, as long as the operation makes sense. The flow is, the caller provides the values, the parameters receive them in order, and then the function body can use them as local variables. It's a clean, predictable handoff. Now, positional arguments are fine when a function only takes 1 or 2 params. But once you've got 3 or more, it gets really easy to mix up the order and introduce bugs. That's where keyword arguments come in. Instead of relying on position, you explicitly name the parameter when you call the function. So instead of greet open parenthesis, quote, Alice, quote, comma, quote, good morning, you write greet name equals Alice, greeting equals good morning. Way more readable. It's basically self-documenting code. And here's a bonus. With keyword args, you can pass them in any order. So greet open parenthesis greeting equals quote, hello quote, comma, name equals quote, Bob quote, close parenthesis, works just fine. This is especially useful for functions with lots of optional config params. Think API calls, sending emails, that kind of thing. Default parameters take this one step further. You can assign a fallback value to a parameter right in the function signature. So if the caller doesn't pass that argument, Python just uses the default. Like defgreet open parenthesis name equals quote, guest quote, close parenthesis. Call it with no args and you get hello guest. Pass a name and it uses that instead. This is super useful for things like pagination. Def fetch underscore data open parenthesis page equals 1 comma per underscore page equals 10 close parenthesis. Most callers just want the first page with 10 items, so they don't have to pass anything. But if they need page 3, they can. It's also a great pattern for backwards compatibility. You can add new parameters to an existing function without breaking any code that already calls it. Just give the new param a sensible default. Alright, so far our functions have been doing things, printing output, running logic. But the real power comes when a function returns a value. The return statement sends a result back to whoever called the function. So square open parenthesis 5, close parenthesis returns 25, and you can store that in a variable, use it in an expression, or pass it straight into another function. Python also lets you return multiple values at once. Just separate them with a comma, like return min underscore val, max underscore val. Under the hood, Python packs those into a tuple, and you can unpack them on the other side. One thing to know, if a function doesn't have a return statement, it implicitly returns none. That's fine for functions that just perform actions. But if you expect a value back and get none, that's usually a bug. Be intentional about it. Let's put arguments and return values together in a real example. We're building a modular calculator. And the key design decision here is that each operation gets its own function. Add, subtract, multiply, divide. Each one does exactly one thing. Then we have a calculate function that takes two numbers and an operator string and uses a dictionary to dispatch to the right function. This is called dictionary dispatch, and it's a really clean pattern. Notice the divide function has a guard clause. It checks for division by 0 before doing anything and returns an error string early. That's much cleaner than wrapping everything in a try except. Each function here is small, focused, and independently testable. That's the single responsibility principle in action. Sometimes you genuinely don't know how many arguments a function is going to receive. That's where args and quargs come in, and yes, the names are just convention. The stars are what matter. Asterisk args collects any number of positional arguments into a tuple. So sum underscore all open parenthesis 1, 2, 3, close parenthesis, or sum underscore all open parenthesis 10, 20, 30, 40, close parenthesis. Both work, no problem. Star quargs, that's double star quargs, short for keyword arguments, collects any number of named arguments into a dictionary. So you can pass in name equals Alice, age equals 30, role equals engineer, and iterate over them. You'll see this pattern a lot in frameworks like Django and Flask, where functions need to accept arbitrary config options, and you can combine both. Deffunc open parenthesis, asterisk args, comma, asterisk, asterisk, quargs, close parenthesis. That's the most flexible signature you can write. Lambda functions are basically throwaway functions, one-liners with no name. The syntax is lambda parameters, expression. So lambda x times 2 is a function that doubles its input. They're not meant to replace regular functions. They're for short, one-off operations, especially when you're passing a function as an argument to something else. The classic use case is sorting. If you've got a list of dicts and you want to sort by a specific key, you pass a lambda as the key argument to sorted parents. Same deal with map parents and filter parents. Lambdas are perfect there. One PEP8 note though, don't assign a lambda to a variable like f equals lambda x colon x. If you're naming it, just use def. It's cleaner, it's more debuggable, and it's what the style guide recommends. Alright, recursion. This one trips people up at first, but once it clicks, it's genuinely elegant. The core idea is simple. A function calls itself. Instead of solving a big problem all at once, it breaks it down into a smaller, identical version of the same problem, and keeps doing that until it hits a trivially simple case it can answer directly. The Fibonacci sequence is the classic example. To get fib of 5, you need fib of 4 plus fib of 3. To get fib of 4, you need fib of 3 plus fib of 2, and so on. Now here's the thing you cannot skip. The base case. That's your exit condition. For Fibonacci, it's if n is 0, return 0. If n is 1, return 1. Those two lines are what stop the whole thing from running forever. On the right side, you've got the three concepts to keep in your head. The recursive case, that's where the function calls itself with a smaller input, moving one step closer to the answer each time. The base case, the essential exit condition, the thing that stops the chain. And the call stack, every recursive call gets pushed onto Python's call stack as its own frame. Once the base case fires, the stack unwinds, and each frame passes its return value back up the chain. That unwinding is where the actual answer gets assembled. One hard limit to know, Python's default recursion depth is 1,000 calls. Hit that without a base case and you'll get a recursion error. So always define your base case first. Decorators are one of those Python features that feel like magic the first time you see them. But once you understand what's actually happening under the hood, they make total sense. The key insight is this. In Python, functions are first-class objects. That means you can pass a function as an argument to another function, return a function from a function, and rebind a name to a completely different callable. A decorator is just a clean application of that idea. Look at the timer decorator on the left. We define a function called timer that takes another function, func, as its argument. Inside, we define a wrapper closure that captures func in its enclosing scope. The wrapper records the start time, calls the original func, measures the elapsed time, prints it, and returns the result. Then timer returns wrapper. Now when we write @timer above our compute function, Python immediately executes timer compute and rebinds the name compute to the wrapper object. The original function still exists in memory, it's just referenced by the closure now. So every time you call compute after that, you're actually calling wrapper. It runs the pre-logic, delegates to the original via the closure, then runs the post logic. And because wrapper uses star args and double star quargs, it's completely transparent. It'll forward any argument signature the original function accepts without breaking anything. This pattern is everywhere in production Python. Logging, authentication, caching, rate limiting, decorators handle all of it cleanly without touching the original function's source code. All right, let's put everything together in a practical exercise. We're building a simple banking system, and the whole point is to show how modular design works in practice. We've got a global accounts dictionary acting as our in-memory database. Then we write separate, focused functions for each operation. Create underscore account, deposit, withdraw, and get underscore balance. Notice how each function has guard clauses at the top, checking if the account exists before doing anything, checking for insufficient funds before withdrawing. These early returns keep the happy path clean and readable. The create underscore account function uses a default parameter for the initial balance, 0 by default, but you can override it. This is exactly how you'd structure a real module before you start wrapping things in classes. Clean, testable, and easy to extend. Getting a function to work is the easy part. Writing one that your teammates and future you can actually understand and maintain, that's the real skill. Three big ones here. First, naming. Function names should read like verbs. Calculate underscore tax, fetch underscore user underscore data, validate underscore email. If you can't describe what your function does in a short verb phrase, it's probably doing too much. Second, single responsibility. One function, one job. If your function is validating and formatting and saving data, split it up. Smaller functions are easier to test and reuse. Third, doc strings. Use triple-quoted strings right after the def line to document what the function does, what the params are, and what it returns. Your IDE will pick these up, help, will display them in the REPL, and your teammates will love you for it. Even experienced devs get burned by these. First one, mutable default arguments. This is a classic Python gotcha. Default argument values are evaluated once at definition time, not every time you call the function. So if you use a list as a default, that same list object gets shared across every call. The fix is to use none as a sentinel value and create a fresh list inside the function body. Second, overly complex functions. If your function is more than about 20 lines, that's a code smell. Break it into smaller helpers. Third, global variables. Relying on global state makes your functions unpredictable and nearly impossible to unit test. Pass data in as arguments, return results explicitly. Functions that don't depend on external state are called pure functions, and they're much easier to reason about and test. So where does all this actually show up in the real world? Everywhere. In data engineering, functions are the building blocks of ETL pipelines. You've got extract, transform, load, each one independently testable and chainable. In web dev with Flask or Django, every URL route is literally a Python function. That at app.root decorator you see in the code example, that's just a decorator registering your function as an HTTP request handler. And in data science and machine learning, functions are how you wrap pre-processing steps, feature engineering logic, and custom evaluation metrics so they're reusable across notebooks and pipelines. The bottom line, functions aren't just a beginner concept. They're the backbone of every serious Python codebase. Master them, and everything else gets easier.